Hi friends, I am VYSAKH K.V, Assistant Professor, Department of Mechanical Engineering. Today I am discussing about the basic concept of photoelasticity and its application. Photoelasticity. Photoelasticity describes change in the optical properties of a material under mechanical deformation. It is a property of all dielectric media and is often used for experimentally determine the stress distribution in a material, where it gives a picture of stress distribution around the discontinuities in materials. Photoelasticity is an important tool for determining critical stress point in a material and are used for determining stress concentration in irregular geometries. What is stress? Mechanical stress is a term from strength theory, a branch of technical mechanics. It is the force per unit area that acts in an imaginary section through a body, a liquid, or a gas. The mechanical stress has the same physical dimension as the pressure, namely force per area. The pressure represents a special case of mechanical tension. Pascal or Newton per square meter, as well as megapascal or Newton per square millimeter, are common in practice as a unit of measurement for mechanical stress. Light and refractive index. Light is an electromagnetic wave that causes atomic shell to vibrate, which in turn to generate light. The velocity of light in a material depends on the particle density. The refractive index is the ratio of the light velocity in the vacuum and in the material. The refractive index n equal to speed of light in vacuum divided by phase velocity of light in the medium. Stress birefringence. Mechanical stress lead to deformation of the material structure and therefore change in the particle density and the velocity of light. If the velocity of light varies in different direction, the material is called birefringent. Glass normally is optically isotropic but become birefringent when put under mechanical load. Polarized light. Light moves through transparent material in the form of waves. The frequency of the waveform varies with the type of light. The standard wavelength of a white light through glass is 565 nanometer. These waves are omnidirectional and vibrant out at the perpendicular angle from the direction of the light beam. When light passes through a polarized lens, all components of the light wave are blocked except for the component of the light wave in the plane of vibration allowed to pass by the polarization filter. Linear polarization of light. If the electric field of light oscillates only in one plane, this is called linearly polarized light. A linear polarizer let pass only those light waves which are oriented parallel to its optical axis, thus producing linearly polarized light. Circular and elliptical polarization. In a birefringent material, the light wave propagates in horizontal and vertical directions at a different speed, resulting in an optical path difference or optical retardation. Linearly polarized light leaves a birefringent material as a superposition of two mutually perpendicular light waves of different phasing. If the optical retardation is extremely 1/4 of the wavelength, the light is circularly polarized. In the general case, the emergent light is elliptically polarized. The elliptically is a measure of stress birefringent. Polariscope. Polariscope visualize stress based on interference colors. Neutral area red-violet color, area with stress blue and yellow color. Polariscope allow a quick assessment of stress. It is an accurate measurement tool for stress analysis. POLARISCOPE structure and working principle. Polariscope with two crossed polarizers show colored image with birefringent materials and white light source. Stress birefringence generate elliptically polarized light that partially passed the second polarizer. The degree of extinction depends on both birefringence and wavelength. If the color is filtered out of the spectrum, the remaining light assumes the complementary color. The interference color can be translated into retardations using color scales. We can conclude the presentation. Photoelasticity is a wall field technique for measuring and visualizing stress and strain in structure. The method utilizes a birefringent model of an actual structure to view the stress contours due to external loading or residual birefringence. When white light is used for illumination, a colorful fringe patterns reveal the stress or strain distribution in the part. Quantitative analysis such as strain concentration points, uniform stress region, etc. can be identified quite readily. For quantitative information, a further analysis has to be performed. Up to quite recently, this was done by transforming the color patterns to a black and white picture by utilizing a monochromatic light source of illumination. Using monochromatic light source enable better definition of fringes, especially in the area with the dense fringes as the stress concentration points.